Now there's no reason we can't continue going around the circle and around the circle and around the circle, either way, for either function. So that it should be clear that if we do go around the circle again, we're just going to continue whatever pattern we have, and we would get another copy of this curve appended right here, and then another one here, where this axis corresponds to the arc distance, total arc distance we've moved since we started. So that we could extend the graph of the sine function, let's say just this far. It could extend much further, but I don't want to take the time to draw it much further than that. I do want to have this part of it to illustrate what I'm going to illustrate here, okay? And it is what I'm going to illustrate is simply, first of all, graphically, this is at least plausible, that each point from the sine function is shifted the distance that corresponds to one quadrant to the left or if each point of the sine function, each point on the graph of the sine function is shifted a distance corresponding to one quadrant, the arc of one quadrant to the left, we land on the same points that we had for the cosine function. Okay, so I'm going to suggest a proof. Prove the leftward shift corresponding to the arc of one quadrant, and it should be clear what I mean by that. Can I didn't write down everything I should have, so I'll say leftward shift of the points of the sine graph corresponding to an arc of one quadrant lands us in the corresponding points of the cosine graph. Now, ordinarily, I'd write this out before I start talking on the screen for two reasons. One, so I can correct little glitches like that, but the other, because this is really, really important. Okay? Why is it? When I say prove, well, how do you prove? You start by asking yourself, why is it that this point lands on this point lands on this point, this point lands on this point? And the answer to that is fairly straightforward if you really understand what's going on with these circles and how they relate. So I think that's a reasonable thing to ask you to attempt to prove. You might not get a publishable mathematical proof out of it, but you should get, hopefully we'll get a decent explanation of why this is. Now, you know that we could continue subdividing either of these circles to get a dense set. And this is going to be true. This is true for the 8 points that we've graphed here. There's no reason that it wouldn't be true for all the subdivided points. So it would be true for all the points on the dense set. And as a result, we can say that the closure of that dense set for the sine graph, when moved to the left, distance corresponding to one quadrant, is going to give us a dense set for the cosine graph. So this also gives us a way of constructing the cosine graph without having to go through this process. All we have to do is shift the sine graph 1/4 of a cycle to the left. So alternative construction of the cosine graph shift the sine graph one-quarter cycle to the left.